Hi, so my name is Zidane Theo Ramos, and with my group, I guess we're gonna explain how motors work. The first step on figuring out how a motor works is by making one yourself. Like, listen. Look at this bad boy. I made a motor by myself. It was really nice. I was really time constrained because my dad left. But look at this. It looks really scuffed, but it works. The motor was so good that honestly, I felt like I was Peter Parker for a second. But anyway, there are seven parts to this video that we'll have to discuss. I guess technically six to understand to basically understand what a motor is or how it works or whatever. So the first one is technically making the motor itself. So I didn't check that out. But the second one is
Electric motors and generators both have the same five basic parts, which are the rotor, stator, commutator, brushes, and the power supply. The rotor is located inside the stator and is mounted on the AC motor shaft. It is the rotating part of the AC motor and is also referred to as the armature. In the electric motor, the stator is the coil of wires which provides a magnetic field which drives the rotating armature. But in an electric generator, the stator converts the magnetic field into an electric current. Brushes are metallic contacts which are supposed to connect the armature to the battery so that a current is maintained in the coil. They are supposed to stay set even if the armature is rotating.
damn. That you kind of said a lot. I guess it's more clear that way. The third one is about
One of their differences is that an electric motor is a machine that converts electrical energy to mechanical energy. On the other hand, a electric generator is a machine that converts mechanical energy to electrical energy. And the difference between their principles is that the motor is based on the current carrying conductor that experiences a force when it is kept in the magnetic field. But the working principle of the generator is based on the electromagnetic induction. These are their main differences that are important for us to know to better understand their uses.
and then straight to the fourth.
4. Describe the energy conversions that take place in a motor and a generator. The energy conversions for the two devices works the other way around. While motors converts electrical energy into mechanical energy, generators convert mechanical energy into electrical energy.
Honestly, I myself don't understand how this works, but and the fifth one,
5. Explain the factors affecting the speed of the rotation of the motor's armature. The speed of the rotation of the coil in a DC motor can be increased by increasing the strength of the current, having more turns in the coil, increasing the area of the coil, and by increasing the strength of the magnetic field.
the sixth one is more related to. No, it's still science, but there's some math into it. That's why it's called a math sci project. The sixth one is the movement of an object around the circumference of a circle is known as circular motion, or rotation along a circular path. Electric motors can provide circular motion. A linear array of electromagnets can push against a linear array of magnets comparable to an unwinding electric motor. Now finally, the seventh one is some uses of an electric motor. As you can see from the clips that I'm making right now, we have a vacuum, a water pump. What's a water pump? We have a washing machine, an AC, aircon, not an alternating current, an electric fan. I think we all have these things in our household. That is how a motor works. Woo! You gotta celebrate now. You know what a motor is. But now, how are you gonna make a generator? Huh. A generator is basically the opposite of a motor. Oh yeah, I want you to try to do it. I'm challenging you right now. If you don't do it, I'll go to your house and eat all of your pizza.